Hey guys, in this short video, I will talk about the bare minimum knowledge that you need to start your journey into the world of graph databases. Specifically, I will talk about the basic structure of a graph. This is also referred to as the schema of a graph schema. The concept of a graph is really simple. At its core, it only has two things, which are vertices and edges. On the screen here, the circles represent the vertices and the line represents the edge. Sometimes these vertices are also referred to as nodes, but I will try to avoid using that term because the term node is also used to refer to a machine in distributed system. We are going to stick to vertices and edges. For the rest of the video, we'll use sample schema representing the relationship between two people, Bob and Alice, to show the various concepts of graph schema. So let's say Alice and Bob are friends. You can represent that relationship using one vertex for Alice, one vertex for Bob, and a line between them indicating the relationship between Bob and Alice, which is, in this case, one of that of friendship. So now let's drill down a little bit deeper and look at some more details of this graph schema. The first thing to note is that these lines, edges, can actually be arrows, meaning that they point in a particular direction. In our example, the arrow might mean that Bob is the one who initiated the friendship. The thing to remember here is that whenever the edge has an arrow, the graph is called a directed graph. Otherwise, it is called undirected graph. One counterintuitive thing here is that if an edge does not have a direction, in some graph implementations, it actually takes more space to represent this edge on disk and memory than if the edge had a direction. And the reason for that is that when an edge does not have a direction, the implementation actually creates two edges under the hood, one for pointing to the vertex on the left, Bob, and the other one for pointing to the vertex on the right, right? Long story short, whenever possible, make sure your edge has a direction. Next, let's zoom into what can be stored inside a vertex. So there are two types of things that can be stored in a vertex, labels and properties. Labels indicate what kind or type of a vertex it is. So in our example, we can say that the vertex Bob is of type person. Vertices can also have multiple labels. This can be a little bit confusing initially, but this concept of a vertex having multiple labels comes in handy when you want to represent polymorphic object in a vertex, meaning an object which has multiple types. In our example, we can say the vertex is not only a person, but it's also of the type of employee. So Bob is a person as well as an employee. The second type of information that a node has called properties, which are simple and name value pairs, and these store additional information about the vertex. In our example, a property might be the name of the person the vertex represents. Another property might be the age of the person. The third property could be the address of the person, and so on. There is no theoretical limit to the number of properties that you can put in a vertex. One thing to note is that the properties that gives the vertex its identity can be called as an identity property. In this case, the name property is what gives the vertex an identity. In fact, the reason I've been calling this vertex Bob is because the value of the name property is Bob. So properties are what gives the vertex its identity, and labels tells us the type of the vertex. Property, identity, label, type. So let's go back to our original graph and look at the edge itself. The way an edge indicates a relationship is also using labels. In our example, the label here is called friend, which indicates a friendship relationship between Bob and Alice. One thing to note here is that unlike nodes, an edge can only have one label. Nodes can have multiple labels, but an edge can have only one label. And that is because one edge represents only one relationship. Now, in addition to the label, edges can have multiple properties. And just like nodes, they are also name value pairs. This is to store additional information about the edge in the edge itself. Now, in our example, one property, as you can see, could be the start date of the friendship. Another could be the strength of the friendship, and so on. You can add as many properties as you want on a edge. Let's bring it all together. So in our example, we have one vertex for Bob of the type person, as well as an employee with properties indicating his name, age, and address. Then we have another vertex for Alice, who is a person and a contractor, and properties indicating her name, age, and address also. And finally, we have the relationship between Bob and Alice being represented by the friend edge. Not only does the edge tell us about the type of the relationship, it also tells us when it started, the strength of the relationship, and since it's directed, who initiated the relationship. So I hope this gives you an idea of how rich the data in a graph can be and the potential a graph database has to store your own business information. So to summarize, here are 5 things that you need to remember at a bare minimum about graphs. And these are vertices, edges, directions, labels, and properties. Vertices can have multiple labels and multiple properties. Edges can have one label, multiple properties, and an optional direction. And I hope this was useful and it helps you the first step into the world of graph databases. So our next video will be about how to get started playing with Neo4j, which is a popular graph database. Thank you.